Welcome back to Quote Unquote videos. Today we will have a look at Intro to Cyber Threat Intel Room, and we will learn what is that threat intelligence and why it matters. Also, there will be a secret animal shown in the video, so make your guess who it is. Task introduction, we have a mentioning what is the discipline of cyber threat intelligence into everyday task. It's enriching indicators, triggering alerts, and turning raw data into the stories that matters. You can read more about it and press complete. So task 2. You as a SOC analyst, you will need to answer these 3 questions, which is cyber threat intelligence questions. And we have who or what is on the other end of the alert indicator. Do you know this person? Is it employee of your company? Is the IP address the same as your company IP address? Or maybe it's unknown, unauthorized request to access your company's login system. So what was their behavior in the past? Maybe it's political disagreements, which can be another country has the hacker team that try to get access to your country data, private equity, and that could be also the behavior that you will need to consider. Or maybe you're working in a company, like for example oil company, and someone from the climate activist try to hack your company and get your data because they have disagreement with your policy as a company. So that's, you will need to analyze what kind of the behavior in the past maybe this team has. Do they have some patterns that you can recognize and assume that they come from that type of team? So how does my organization respond and what should I do about it right now? In this question you answer as a part of the organization, because what you will do at this stage will consider what the organization best interest in this response will be. So will be allowed the access from unauthorized computer or location, or will it be blocked immediately? So you will need to answer that question as well. And we have here 3 type of terms that we will include as well, which is data. Data is unprecedented observable, and it's IP address, port number, any type of data. Maybe a log file also can consider data if it's especially not sorted, so just random, so it can be raw data. This is captured the artifact. And now we have information. Information is data plus factual notation. So remember, when you log in into some account, for example Google account, you received a message, your login was fixated at this location, and if it's not your, please change your user credentials. So that will be information. When you have IP address and it's first seen at this date, and they basically keep record of the attributes. Intelligence. Intelligence is when you analyze information and answer so what. You receive this information, you analyzed it, and now you have to take actions, for example block immediately. Now we go to 3 more labels. I will skip enrichment, you can read more about it here, over here. And now we go to these 3 in labels, which is indicator of compromise, evidence of the breach, a C2 address in the logs. What does it mean? It means that malicious server is connected to your machine, and you can see this basically in the logs file. Indicator of the attack. When you can see that the PowerShell is launched unknown service, maybe executable service or anything like kind of suspicious, that's a malicious action. That's a second part of indicator of the attack. The techniques and procedures, that's basically the methodology, and it's describing in the MITRE attack description for each category of the attack. that is existed at the moment. Maybe there is more to come. So we will use these terms in a short form, which is ISE, IOA, and TTP. And as you can see over here, it's associated the indicator of the attack or TTP examples. And what the type of the indicators is the most essential for the first line triage. So this is like the most common one, and this is IP address, domain, URL, file hash, email address, and local artifact. You can see each example for each indicator, and here we have the first resource, so where you can find them, and associated indicator of the attack, and tactics, techniques, and procedure examples. So for each one of the categories, so for example, how we can see them in the use. A CM launcher panel. A CM launcher panel, it's basically the main dashboard that SOC analysis deals with. In the CM launch panel, if you are in a system, like the system has the server, the system has other computers that are connected to the system in basically the company, and or home lab, whatever you call it, and that's basically you're gonna have the dashboard of representing each one of the connection. How is it connection failed or is it not? What the alarms? Is it too many queries all of a sudden goes into your system or anything else? You can also put CM on your own computer and see the CPU usage and internet usage, anything basically. How does your file take the space? Which one is the most filled, etc. Feeds, platforms, and why distinction is matter. So feed is a scheduled stream of indicators. We can receive this through various like text files. Basically it's CSV, JSON. It's basically have they organized, so this indicator and the variable, etc. Platform is the repository that stores the indicator, and here we have OpenCTI, which is leading open source example. And that's basically how does it look like in the dashboard. You can see the labels, you can see the correlationship, the map, everything. That's a platform for using the feeds. So the feeds is the stream of indicators, which is basically raw data, and the platforms where you can see it. Next one, source of type of cyber threat intelligence. So we have a couple of them mentioned here. This is internal telemetry, which is CM logs, and EDR detection, phishing mailbox, etc. Commercial service. So we have paid sandboxes. Sandbox, remember, it's when we are on the malicious software to see if it's safe to open. So basically it's isolated environment. Open source intelligence, and that's basically the act of analyzing and gathering publicly available data. And here's the example of the platforms where you can find it, which is public logs, academic research, anything that can be related. And next one is community and ASAC. This is basically a sector-specific listed market with labels and rich context. Threat intelligence classification. So there's strategic intel, which is basically the long-term understanding of the threats that come in, the patterns that emerge, and the long-term effect on your business. So that's where you make business decision about your security. Tactical intel. Tactical intel is when you go through the behavior, analyze the tactics and procedures that attacker may use, make notes, etc. Operational intel. Operational intel is when you have motives, intent to perform the attack. So, for example, you have the financial department, and you know that financial data can be a weak point. So you need to concentrate your security system to protect this financial department, which can be people, processes, technologies, etc. Technical intel is basically the indicators of malicious behavior. It can be also the list of malicious website, IP addresses, etc. So that's the technical part of the intel. So let's go to the questions. What does STI stands for? And as you remember, it's Cyber Threat Intelligence. It was mentioned over here. Cyber Threat Intelligence, STI. And you can see. Okay. Next one, IP addresses, hashes, and other threat artifacts would be found under which threat intelligence classification? So remember, here was the classification, and the IP addresses and hashes, that's basically the technical intel part. So CTI Lifecycle is divided by 6 phases. First one is planning and direction. So you make a plan of your direction, all actions. Next one is collection. You collect the data. It can be collected from the software, hardware, any information that you can collect and you need to collect, you collect in that phase. Next one is processing. It's when you need to clean the data before you analyze, or maybe there is missing values, or you need to categorize by certain categories, sort it, etc. So then the fourth one is analysis. That's the part when you need to perform the action. You need to understand the data, analyze it. Is it important to keep it, or is it needs to be performed some actions? Next one is dissemination. It's basically the news, sharing, etc. So maybe you refer it to another colleague or something else. Sixth one is the feedback. Maybe you receive the instruction that you should block this IP address from your supervisor or etc. So that's the feedback. Traffic light protocol. Traffic light protocol is the coloring labels, and there is 4 labels existing. So first one is clear. There is no restriction at all. You can share this information with anyone you want, social media platform, internal Wikipedia, anything like this. You can share it. And please also note that the data can be change the label of the traffic protocol as we go through. So for example, if the movie has not been finished, it would be restricted access. But if it's finished and you want everyone to see it, then you will need to change the label to the clear for your trailer. I mean, not for the movie, because you want people to pay for it. So it will be only for the trailer. You will change the data label to clear. Next one, we go to the green, which is share with the peer community but not publicly. So in the movie example, it will be in like for example Netflix platform or Amazon platform, so where you can watch the movie, but still you need the subscription or maybe paid services or anything like this. That will be a green flag. Over here is example of the Slack workspace restricted to the partner. Amber classification, that's organization wide. So external sharing will be only to known clients. So if you need to share some information and you need to make sure that's a trustworthy client that you're sharing the information with, since this data cannot be copied or referenced. Next one is red, named recipients only. So if you don't know who you are sharing this information with at all, by name, by person, you cannot share it at all, because it's the red is the highest restriction on the traffic light protocol. So this data absolutely needs to be stored encrypted. Do not post ticketing system without the clearance. So for each request, we have the ticket system. And here, for example, you can store the information in the ticket. Maybe it's a malicious IP address or whatever, and you put it amber. You don't actually encrypt that information, obviously, but if the information is even more sensible, then you encrypt it and it's categorized as read. So next one, we go to the Intel formats. So what formats does analysis use? And that's basically can be protocols, can be structured thread information expression, STIX, JSON scheme. JSON is really popular for storing the information, like thread indicators, relationship, etc. Next one, we have scenario premises. We have a corporation, which is TryHackMe, that holds sensitive customer data in a PostgreSQL server. And we have a person, Alex, that morning shift L1 analyst. And he is assigned to build and exercise the workflow. So what is the step one in direction that Alex needs to go through? That's the primary asset. We have a PostgreSQL production database, and we have a look if there is any leakage in the data or anything that we need to concentrate on. That's our primary asset. What is the business risk? So the business risk is if data gets breached, then you lost customer trust. Maybe there's customers will be, oh, I don't want my data to be stored in this company. They all the time getting hacked. And the third one is available controls. NGFV is next generation firewall, and this basically firewall that we have to protect our database and IP and domain based blocking system. So that's part when we control our protecting system. Next one is initial CTI goal. Remember, CTI is threat intelligence, and what we have. So we have a threat feed indicators, and maybe we need to block or alert suspicious IP address, etc., detect unknown malicious file hashes. Next one, we have a questions over here, 2 measurable questions. Question 1. Which external IP address and domains are currently used to exploit PostgreSQL service or exfiltrate database records? So is there any IP addresses or domains that currently connected to PostgreSQL and they may be not protected or not protected enough? That's basically the question. Helps us answer how secure is our database. The question 2. Which malware family is targeting PostgreSQL drivers? So that means that not all malware will be applicable for our PostgreSQL. So there is some malwares that maybe SQL injection in the text fields or anything like this that can be considered a malware family that could target our PostgreSQL database. And what are their file hashes? So if we know them, we can block them, and that will be really great for us because we will have one more step to make sure our database secure enough. Step 2. Collection, assembling the raw data material. So we have a couple of sources over here from the Alex. So first one is commercial feed from next generation firewall vendor. So as it shows over here, that's basically how it's implemented the firewall from the another maybe vendor, and we have protection. So instead of building our own firewall, we used next generation firewall that is provided by the third party vendor. The next one is open source project, and that's basically filtering PostgreSQL brute force. So if we found some IP address or anything like this or domain that we don't know or want to report, we can report over here. The malware information sharing platform is internal to the company, so that's basically historical view of the incidents. Inside of the company, they have their own historical view of any incidents that happened inside of the company since the company is created, unless they lost this data. So, and also we have over here the open source community, which basically also keeps track of the historical data, and you can read documentation, community, etc. Vendor threat report releases this week. So that's basically one new malware hash or 3 basically malicious domain. That's strategic insight distilled into technical IOC. So if our vendor is getting basically targeted by some malware, then we should obviously know about it before we getting targeted as well. Step 3. Processing, normalizing and correlating the data. Raw feeds never align perfectly, and it says we receive the data in a mixed formats. So Alex ran executing schedule Python script, which will normalize, correlate and duplicate, tag and converts. Normalize is basically when we have IP address, we would want it to remove the IP submask. When we have a domain, we would want it all domains be in lowercase. Correlates and duplicates. For the correlates, we would want it to know. So if the data is already known, then we would want it to be marked as known rather than unknown. For the duplicates, so if we have any duplicates, we would want to keep our data unique and remove any duplicates. Tag each entry with the source, date and TLP label. TLP label we mentioned above, which is traffic light protocol, and it can be as it's amber, clear, etc. So converts, so which means we want our data to be into action files, which is fire block list and hash rules blocking. So Alex spots that in a new generation firewall feed labels as amber the IP address, but in abuse IPDB label is as clear. So one IP address but appears in 2 different labels feeds as different label. So avoid this. Obviously he needs to change it to amber, otherwise if the data will be public and something goes wrong, it will be a big mistake for the company. Step 4. Analysis, turning information into judgment. Blocking every indicator or artifact will be to have a lot of false positives. That's why we look at the Alex example and how he deals with each threat. So the threat is represented over here, firewall indicator. So first goes through the cross-check. So using the span query, he received the data during the 30 days period of time, and he see the IP address attempt but failed open transmission control protocol, and it was the 5432 port and against the production subnet. So he tried to log in into our Postgres database, but login failed. That event validates the indicator's applicability. This means that this threat is real and we need further investigation. So we go to hash indicators. Reverse search using the open CTI links to the new hash. So we go to the and using OpenCTI links, we find the new hash, which is linked to PG Steel malware family, and after running it in any run sandbox analysis, we see that that's basically demonstrate credential dump behavior, which is trying to steal our database data, and the hash is marked as a high priority and relevance is confirmed. So what Alex graded each indicator by confidence, which is high, medium and low. High is basically IOC, which is indicator of compromise in more than 2 sources, and local attempts more than 1 or equal to 1, and also here equal to 2. So the action this needs to be performed is immediately block. Medium, it's a single trusted source, no local hints, so that will be just alert. And for low, which is OS, INT, which is open source intelligence, that's only source which is maybe public information, and the local sighting, it's no context, so you just monitor and look for this around 40 days what's happening. 7 appear as and 1 hash mid higher bar, and the rest are queried as medium and set for monitoring. Step 5. Dissemination, gathering intelligence to the right consumers. So we have the stakeholders, and that's basically 4 teams, which is firewall team, endpoint team, STI platform, and management. As you remember, STI is cyber threat intelligence, and we go through each one of them. So the first one, firewall, will be in CSV uploads plus change tickets. Why do we need it? So they own the blocks rules, tickets, documents, etc. Endpoint team. So that's the Yara rule set. I can show you also what is the Yara rule set. So that's basically something that looks like this. We have the rule example, and we have strings, which is equal, and condition that we set. That's how the Yara rule set works. And ADR console, which is endpoint detection response, that's basically the tools that we use. So why do we need it? To load rules into the policy. Obviously we don't want to check every single file by ourselves. If you have some sort of rules, it will be easier to do so. CTI platform. This is the indicator objects with the full flags. So we keep history of artifacts, support of future correlation, etc. Management is 200-word summary in the weekly cyber risk memo. That's basically a report, documentations, something like this for the procedures. So step 6. Feedback, measuring, and refining cycle. So here we have our metrics and report from the firewalls and NDR reports. So that's basically the end of our cycle phase. And we have the updates and direction documents, closes on the feedback loop, and schedules the second iteration. So that was the 6 cycles, and each one of them was analyzed in each one of the steps. I hope you understood it. So let's go to the questions. At which phase of STI lifecycle data convert into usable formats, sorts, organizing correlations, and representative? So for this one, it's processing. During which phase do security analysts get the chance to define their questions to investigate the incident? That will be the phase which is direction, which is the first one. And let's move to the task 4. So let's go over standards and frameworks. MITRE, ATT, and CK. That's basically the ones that we already went through the previous rooms. And we here have meshed behaviors and alerts, tactics and techniques and procedures. So basically methodologies that we use. MITRE, T3, F, and D. So that's a catalog which use for defenders how to respond. And we have over here example of DNS tool alert and basically request analysis, block extensivity. And that's how this catalog work, and that's kind of like a framework that you can use to help you to plan your actions and mitigations. Our secret animal today is squirrel. That's a cyber kill chain. We went through this already, each one of these techniques. And now we go to SVIs and SVSS and the NVD. SV is common vulnerabilities and exposures. So let's provide a catalog number for discovered vulnerabilities. And the common vulnerability scoring system, which is SVSS, it can be scored from 0 to 10 of severity scale, and with temporal and environmental modifying for vulnerabilities. The next one is National Vulnerabilities Database. That's a repository which is linked to SVE, as we have over here, common vulnerabilities and exposure numbers, to our common vulnerabilities scoring system, exploits and affected products. It's quite technical, this term, so I hope you will get it. Sharing and processing intel. So STIX over here, that's basically how we share our vulnerability, or maybe we use it as in JS on scheme to describe our threat information. TXI, it's trusted automated exchange of indicator information, so that's another platform to share your basically threats, indicators, real time for detection, prevention, mitigation threats. That's how you share it. And you can see over here the tags IA, it's basically the method exchange information, which is STIX is the language enabling organization to share it, the threats. So that's basically method, that's language. Please remember. Now we go to the two sharing models. First one is collection, which ensures threat intelligence collected and hosted by producer, which will make sure there is no stolen information or something like this. Now we go to the channel, which publishes the threat intel to users from the central server. That's our channel, and basically it's real-time feeds. Although remember that not all threats should be disclosed and shared publicly. For that we have privacy laws, consumers and NDAs. So please remember, your company policy is the one that you should be aware of, which threats to share, which not, etc. So what is the sharing models are supported by TAXII. It's collection and channels. When an adversary has obtained access to a network and is extracting data, what phase of the kill chain are they on? So that's basically actions on objectives. They extracting data, they moving out, that's the last phase. Okay, we go to the task 5. So let's go to practical analysis. We click on the button and it says over here that we need to open the static site lab and navigate through security monitoring and answer the threat details questions. So what was the source email address? As we can see over here, internal network traffic detected, email received from John Doe, and it obviously has badbank.com, so that's our answer for the email address. Also notice that here it's a CM internal, so that's internal platform of the company. So we place the email, submit. And it's also over here as well. It is asking us was the threat actor email address. So we answered. Next one, what was the name of the file downloaded? So through this account that after John received the email from this bank, John opened and downloaded the file, which was called like this, executable. So let's also mention that tool in malware tools. So we copy and paste. Now we go to the next one, IP address. The IP address was accessed from this one, and after we receive the email, user victim logged on logged account. So the one that logged on, that's administrator. At the victim email recipient, that was our John Doe. And here we receive the flag, we copy the flag and paste it. Thank you.